Okay, so we're going to see now, so there are some equivalences that are very useful for computations, and I'm going to write them now here. This is the logarithm of 1 plus epsilon sub n is equivalent to e to the epsilon sub n minus 1, which is equivalent to the sine of epsilon sub n, which is equivalent to the tangent of epsilon sub n, which is equivalent to epsilon sub n. Okay, where epsilon sub n is a sequence such that the limit of epsilon sub n is 0. Okay, so this is a decreasing sequence. So you could take, for instance, e sub n could be 1 over n, or it could be 1 over n squared, something like that, right? Something that is going to 0. So this string of equivalences is very useful. I'm going to prove them now to you. Okay, so let's start with the first ones. So we have the limit, we've seen it before, the limit of 1 plus epsilon sub n to the 1 over epsilon sub n is e, right? Remember that? So remember we had the limit when n goes to infinity of 1 plus b sub n to the c sub n, where b sub n goes to 0 and c sub n goes to infinity, was e to the limit when n goes to infinity of b sub n times c sub n, right? Well, in this case, we have 1 over epsilon sub n goes to infinity, so it's a valid c sub n, and epsilon sub n goes to 0, which is correct, but the limit of, in this case, the limit when n goes to infinity of epsilon sub n times 1 over epsilon sub n is 1, right? So this is e to the 1 e, okay? Okay, just to remind you. So we have this. Now we take logarithms here. So we have the logarithm of this is the logarithm of this. The logarithm of the limit is the same as the limit of the logarithm, we know that. So this is the logarithm of 1 plus epsilon sub n 1 to the 1 over epsilon sub n, and equal to the logarithm of e, which is 1. And this is the limit when n goes to infinity, and because of the properties of the logarithm, the exponent goes out multiplying, so this is the logarithm of 1 plus epsilon sub n divided by epsilon sub n is 1. Okay, so that means that these two sequences are asymptotically equivalent. Okay, so this is what we're saying here. Logarithm of 1 plus epsilon sub n is asymptotically equivalent to epsilon sub n. Okay, so for instance, the logarithm of 1 plus 1 over n is asymptotically equivalent to 1 over n. Okay? Okay, next. So we have the, it's called the logarithm of 1 plus epsilon sub n. This limit of this is also 0, right? Because the limit of the logarithm is the logarithm of the limit, so this is the logarithm of the limit of 1 plus epsilon sub n when it goes to infinity, right? But the limit of this is 1, right? But the logarithm of 1 is 0. Okay, so the limit of this is 0. So we can call this sequence something like delta sub n and take it as our sequence that is going to 0. Okay, and so delta is going to 0, right? So then we have epsilon sub n, and we exponentiate both sides, so we have 1 plus epsilon sub n is delta to the delta sub n, right? And we solve for epsilon sub n, so this is e to the delta sub n minus 1. Okay, so now we have, as we had written before, 1 is the limit when n goes to infinity of the logarithm of 1 plus epsilon sub n over epsilon sub n. This is the thing that we just proved, right? But we can write now these things. This is delta sub n, right? And epsilon sub n is e to the delta sub n minus 1. Okay, so this thing is 1, so this means that e to the delta sub n minus 1 and delta sub n, where delta sub n is a sequence that is going to 0, are asymptotically equivalent. Okay, so this is the same thing. This is this. Okay, so e sub n is a general or any sequence that converges to 0. Okay, so in this case this delta sub n is different than this epsilon sub n, but it doesn't matter because both of them converge to 0. Okay, so this thing is valid. Okay, so we can just change the name of the sequence here. Okay.